of 1/2. Let's figure out what the rate of change for both my graphs is. What does it equal in this case? And then what does the rate of change here equal? If I can determine which one of these has a rate of change that isn't 1/2, then I can figure out which one's the correct graph. It's either A or B. So I know the rate of change is equal to the slope, which is also equal to the rise over the run. So let's pick 2 points. I have some points indicated on the graph here already, so maybe let's pick this one and this one. So there's my 2 points. My rise. If I start here at this left point and I go to this point over here, am I going up to get there or am I going down? Well, it kind of looks like I'm starting here at 6 and then I'm going down to 2. So if I started at 6 and went down to 2, my rise is going to be -4. And then my run is how far am I going across to get from one point to the next. So I'm starting at 0 and I'm ending at 8. So how far across did I go? Well, I started at 0, went to 8. I went across 8 units. In this case, we're talking about time. So -4 over 8 is simplified is the same thing as -1 over 2. And in this case, my units are distance, and I have a time, but I don't know what it's measuring, so distance per time. All right, so that's the rate of change for the first one. Let's do the rate of change for the second one, which is slope again, which is the rise divided by my run. All right, let's pick 2 points here. I need 2 points. I'll pick this one and this one. All right, my rise. How far do I have to go? And in this case, I am actually going up to get from one spot to the next. So I'm starting at 6 and I'm going up to 10. So if I'm starting at 6, going up to 10, I've risen 4. And then my run, how far am I going across to get from one point to the other? Well, I started at 0 and I ended at 8. So I have 4 over 8, which is 1/2. So kind of referring back to the question, it says one of these graphs has a rate of change of 1/2 and a vertical intercept of 6. So they both had that same vertical intercept of 6. But the second graph, graph B, had the rate of change of 1/2. So when it asks which one has it, which doesn't, definitely talking about B. One thing to kind of recognize just immediately by looking at the graphs, the first graph was going down and to the right. That means this graph has what we call a negative slope. This one's going up and to the right, so this one has a positive slope. So if I can represent or kind of just look at it, I wouldn't even have needed to have done those rate of change calculations because I could just see that the slope in my first line is going down and to the right, so it's negative. And it was, in fact, negative because I had to go down to get from my one point to the next. Because I had to go down, it was a negative slope, so that automatically excluded A because the slope in the question was positive. So the more of these examples you look at, the more you'll kind of see negative slope, positive slopes, and things along those lines. Does anybody have any questions on that? Anything that we covered today? You have questions on? Want to go over? Clarification? I'm going to look at the second half of the learning guide. And I guess the way I did it was I just kind of cut the questions from the first little bit, the solutions I should say, and just pasted it on. So I kind of just butchered a full learning guide into two halves. So we have graphing linear functions, x-intercept, y-intercept. So we just talked about that stuff. Should be pretty good with that. Question number 6. This gives us an equation, 2x plus 5y is 10, using the x-intercept as one point and the y-intercept as the other. So for number 6 on the homework, you have an equation, you have your x-intercept and your y-intercept. Remember when we have an x-intercept or y-intercept, you plug in y is equal to 0, then solve for x. For a y-intercept, you're going to make x equal 0, then solve for y. Then you're going to end up with 2 points, and then you can figure out exactly where your line goes. So that is finding your intercepts, plotting a line. This is the exact same question, number 7, except it is going to just be in a little bit different of a format. Instead of the x and y being on one side, they're both on the same side. Why are some points joined together and some aren't? Graph. Was I done that lesson? Did I include an extra page? I have an extra page. I'm sorry. I thought we were done. Let's just keep looking at the learning guide. Graph on the grid provided using the x and y intercept. That's pretty good. What's the cost of hiring a carpenter for 8 hours? Water tank, 12,000 liters. Identify the dependent, independent, x-intercept, y-intercept, rate of change. All right, so we should be good up to here for lesson 4. So we're at the end of page 9 for lesson 4. I see that Abby has written a question in here. Instead of picking a point on the graph for finding rise over run, couldn't I just use the entire graph? For the question A, we looked, could I do 6 over 12 instead of 4 over 8? Yeah. The only thing you're going to possibly run into with that is, so you're just suggesting we use the entire graph for part A. So let's look at part A here just to kind of, if you have grid points or you have points that go on the grid, you could definitely do that. Sometimes you're going to have a line that maybe doesn't go, like if we look at B, the second point here on the right side, it doesn't actually cross at a perfect grid point. So that method's going to work sometimes, but like right here, I'd have to estimate that, and if I'm estimating, I could be off by a bit. So I'm not going to do it there. But yeah, it's a really cool thing about lines is you can pick any 2 points. I could go rise over run, I could go down here, and then over here, or I could just use these 2 points in the middle, down and over, or I could use, the first and the third, I could do that. Any 2 points on a line are going to have the exact same slope. So it doesn't matter which 2 points you've chosen. I just kind of arbitrarily chose those ones. But if you wanted to use the whole thing, which is easier because you're going from 6 to 0, and then you're going from 0 to 12. So your rise is -6 over 12, which is the exact same thing. You're ending up with -1/2. So any 2 points on a line will give you the same slope, which is kind of an interesting property of lines. Talk a bit more about that. Here I thought I was done, but there's one more example. So this was actually from a different section that I kind of tagged on to the end here because we didn't do it in the other section. All right, so we're kind of asked to plot a graph, and we need to identify a few things before we get started, and then we have a chart down at the bottom. So create a table showing the cost of movie tickets, and we want to plot this. So we need to identify the dependent and independent variable. That's what these blanks up at the top are trying to ask. So the idea with the dependent and independent variable is one thing is dependent on the other. In this case, the number of tickets is going to be our independent, and our cost is going to be dependent. So the cost depends on how many tickets you buy. Okay, how much does a movie cost these days? If I went to a movie, bought a ticket, I haven't been to a movie in a long time. In fact, I can't even remember the last time I went to a movie. Maybe this summer. $7, that'll work. 12. I guess if you're doing like 3D or something, it's a little bit more expensive. Why don't we just kind of split the difference between the 7 and the 12 and just call it 10? Because dealing with tens is nice. If we have to graph tens, that's friendly, not too difficult. So if I bought one ticket for myself, I'm going to pay $10. There's a theater that has $2 movie tickets? That sounds like an amazing deal. $2. Wow. All right, so if I bought 2 tickets, that's $20. 3 tickets is 30, 4 tickets is 40, 5 is 50, and 6 is 60. No calculator required. It's good. Remember, anything we have here, we start with, these are all of our x values. We're going to call these our domain. And all of our y values are a dependent variable. It's going to be our range. All right, so is it a function, first of all? Is there a number that's repeated in my domain? Or is there a number that gives me 2 different values into my range? This is kind of this thing, if you see a 1 appear twice, if I had like a 1 here and then a 1 here, in your domain, then almost always it's going to be a relation. But in this case, each number in my domain gives a unique number into my range. So I'm not giving you a 1 and you're saying, okay, it's a 7, and I give you a 1 again, and you're like, oh, that's a 5 now. That's confusing. That's not happening here. So yes, this is a function. So each, we'll call it element, in the domain is associated with only one element in the range. So I'm not giving you 2 values for any one thing. Identify the independent and dependent variable. So my 2 choices are total cost and then number of tickets. So we could write something like this. The total cost depends on the number of tickets. And from up above, the total cost is my dependent. And number of tickets is my independent. The next part asks me to identify the domain and then the range. And remember, the domain is just all of the numbers in the first set, and then the range is going to be all the numbers in the second set. So these are discrete points. The domain is going to be 1, 2, 3, 4, 5, and 6. And my range is going to be all my second set. So 10, 20, 30, 40, 50, and 60. It's nice when we have numbers in a table, the domain and range becomes really easy. When we're trying to identify the domain and range from a graph or a chart, it gets a little bit trickier because we need to figure out where we started and where we finished and the shadow and what values we're using. When we just have ordered pairs or we have a table, we can just say, okay, the domain is all the x and the range is all the y. And yeah, this is a way of doing domain and range. So I forget what this was called in the learning guide. Let's just jump back. I have it here. I think, so we did this as a list. That's what they're calling it, a list. So it's domain and range. We're representing it as a list because we had a bunch of discrete points. Just kind of an easy way to do things. The last part here asks us to graph the function. So this is maybe the difficult part of this. Our graph should have a title. What should we call it? What would be a descriptive title? When you get into chemistry and physics and even Science 10 for that matter, you need to have a descriptive title. It needs to identify the things you're dealing with. So maybe we'll just call this the cost of movie tickets. Seems like a pretty reasonable title. Bell was reading my mind. Thank you, Bell. You've got a gift. All right, any graph is going to need a vertical axis and a horizontal axis. So I'm going to pull out my trusty ruler, draw my vertical axis, and I will draw my horizontal axis. You could probably make some money with a talent like that, Bell. You should pursue that as maybe a career option A in your plan A and B. All right, I need to label my axes. So I said everything in my first column was the domain. So the number of tickets is going to be the horizontal, and then the cost is going to be the vertical. So I'm going to have a number of tickets here, and then I'm going to have total cost, and in this case, in dollars, along the bottom. All right, I need to use as much of the graph as I can. So I don't want to have like all of my points plotted in just kind of a corner of the graph. I want to use as much as I can. So let's try to space out 6 across the bottom as far as I can, because I started at 1 and I went up to 6. So if I do each square is 1, then I go 1, 2, 3, 4, 5, 6, and I'm done about here. That's not what I want. So maybe I should make each square equal a half. I'll put 1 here, 2 here, 3, 4, 5, and 6. That way I'm going to use about as much of it I can across there. And then my cost is going to be a similar thing. I'm starting at 0, and then I'm going up to 60. So I bet if I go up by every 2 squares is 10, I'm going to probably use about the same amount going up. There we go. Okay, I should plot my points now. I said 1 movie ticket cost $10. I said 2 movie tickets cost $20. 3 cost $30. 4 cost $40. 5 was $50. And 6 was $60. Now this is the million-dollar question. This is the question of the day. Do I connect my points with a line? Yes or no? The question actually asks you to explain, so I will explain it. But what do you guys think? Am I going to connect those points with a line? What does it mean when I connect points with a line? Why would or wouldn't I connect the points with a line? Taylor says yes. Abby says no. We need somebody to break the tie. We have a tiebreaker lurking in the wings somewhere. Somebody going to have a moment of brilliance. Belle, Abby are both no's. I think we've got 3 votes, 2 for no, 1 for yes. And Abby's convinced Anna, possibly, to go with no as well. I think what Abby said was really great. Can you buy half a movie ticket? So let's think about that. I'm going to maybe just draw a little red line here. If I had 0 movie tickets, and if I have a line going through these points, what that means is I have some data here. Like a line is a bunch of little points connected together, right? So that means I have exactly what Abby said, half a ticket. If I bought 1.5 tickets, that would cost what does that cost? $30. Or no, $15. Does that make sense? Can you buy half a movie ticket? Yeah, I'd like a seat and then half a seat for my imaginary friend, or like half a seat for maybe my popcorn, something like that. You can't connect those points together. Oh no, I lost my axis. That's all right. So no, we're not going to connect the points. And yeah, I think you've come around, Taylor, because each dot represents 1 ticket. That's exactly right. We can't have half a ticket. We can't have 0.2 of a ticket or 0.7 of a ticket. We're talking about something like water falling out of a bucket. You could have 1 milliliter, half a milliliter, 1/10 of a milliliter fall out. So that's going to be a continuous line with something like water. But when we're dealing with movie tickets or like something like a donut, you don't go to Tim Hortons and say, hey, can I get 2.5 donuts, please? The lady or man behind the counter would look at you and be like, what do you mean half a donut? Yeah, so we run into a problem. And it's something that happens a lot in math. That's why we are talking about it right now. So let's write this down. We call them discrete data or points. And we don't connect them. Why? Because the points in between are meaningless. Then we could also have continuous data. And these ones, we would connect our points because the points in between are meaningful. So these are the sort of two scenarios we're going to run into with our points. Sometimes we connect, sometimes we don't. You just need to kind of determine whether it makes sense to connect or not. So I'm going to leave you with that thought for today. And we have one more lesson. Yes, one more lesson for Unit 5, Lesson 5. Then we're done. So we're going to finish up this unit tomorrow, which is crazy. We're just flying. And we should also finish up Units 6 and 7 before the winter break. And then Unit 8 will be after the break. And I am going to pre-record all the lessons for Unit 8. So if you kind of want to, you're sitting around bored over your winter break, you want to do some math, you could do that. If you want to start thinking about the provincial exam and things like that, that'll allow you to kind of spend some time on it. So I hope to have all the material to you by the end of the break. And that leaves a couple weeks after the break to go over Unit 8 and review and stuff like that. So that's that. If you haven't submitted the first half of Learning Guide Unit 5, first part, you should do that. And I'll leave you guys with that. So we'll see you guys tomorrow. I do not believe we have planning or English right now. I'm thinking we're done for the day, unless you guys have heard otherwise. So I'll leave you there, and we'll see you tomorrow. Thanks.